Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 14 of a unit motion in a straight line. So let's begin with this class. Today in this session we are going to discuss about the motion under gravity for a freely falling body. If you have remember this, in the previous two classes we were discussing about the kinematic equations for uniformly accelerated motion. In this case we are going to do the same thing with same relations. The difference would be that motion in the motion in the previous classes where generally on the x plane, or generally what we can say is in the horizontal plane. In this situations generally the motion would be in vertical plane. So let's begin with today's class. This is motion under gravity. It's a vertical motion. Okay, now first thing, if our body is dropped vertically downward, then it is say a freely falling body. And if an object is released under the influence of gravity only, if an object is traveling under the effect of gravity only, then it says it's in motion under gravity. It is said to be free fall. You need to remember all these keywords. One is motion under gravity, another is the free fall. When they said that your object is in a motion of free fall, that means your initial velocity would be a 0, your acceleration a would be a g. I hope this g is clear to you. This g is the acceleration due to gravity. Value of g on the earth, value of g on the earth is 9.8 meter per second square. But sometimes examiner asks us to take g is equals to 10, so that calculation can be easier. So please keep this in mind that actual value of g on the earth, actual value of g on the earth is 9.8 meter per second square only. But if question paper allows me to have a value of 10, then and then I can take a g is equals to 10. Otherwise I need to perform my calculation with 9.8 itself. So yes, so when it is a free fall, when object is in free fall mode, its an initial velocity would be a 0, acceleration would be a g, and this distance would be equals to h. Yes, this apple is kept purposefully because you might have heard the story of the Newton, and people says that he was sitting under the tree of an apple and apple falls down, and he thinks that why every object is moving towards the ground only, and it gives him a theory of gravitation. So yes, this apple represents that theory of gravity. Yes, so let's begin with this. Yes, it is in free fall motion. So if it is in free fall motion, if it is in free fall motion, I can take initial velocity would be equals to 0. So now my relations will be changing. How it is changing? Let's look. First, let's look at the our previous relations. What were it? It's a v is equals to u to u plus at. A second relation was s is equals to ut plus half at square. A third relation was v square minus of v naught square or u square is equals to 2 into a into s. And my fourth relation would be distance traveled in nth second is equals to u plus a by 2 into bracket 2n minus 1. This were the relation that I have been using in previous classes. Now I am going to replace a with the g, a first replacement. A second replacement would be, you can write s as an h because it is in height. And let's look that this is v is equals to u plus at can be replaced by this. This is v is equals to v naught plus gt. Here I have considered v naught as an initial velocity. This s is equals to ut plus half et square is has been replaced by h is equals to v naught t plus half gt square. Here v square minus of u square or v square minus of v naught square is equals to 2 into a into s. This is replaced by v square minus of v naught square is equals to 2gh. This s of nth is equals to u plus a by 2 into 2n minus 1. You can write this as an h or s, whatever it is. Doesn't make any difference. It's an Sn is equals to v naught plus g by 2 into bracket 2n minus 1. So if I use this symbolic notation, let me write this. I have used v for final velocity, v naught for initial velocity, t for time, g for acceleration due to gravity, and h for height. So now you might have clear cut idea. You might have clear cut idea of this. So this is my relations of now. When I have been said that when a body is dropped freely, when they said body is dropped freely, what they mean is that please take initial velocity as a zero. Yes, a is equals to g and s is equals to h. So let's rewrite the relation. My relation where v is equals to u plus gt. If I replace this u, if I replace this u with 0, then what I can have is I can have v is equals to gt. That means v is directly proportional to the t, because I know that g is a constant for particular location on particular planet. Yes. Next relation, my initial relation was h is equals to ut plus half at square. If I have been said that my body, my object is dropped freely, that means I have been assigned an u equals to 0. And if I write u is equals to 0, then I can have this relation h is equals to half gt square. We can even write as that h is directly proportional to the t square, as well as if I make an object as a t, it's a t square is equals to 2h by g, and t is equals to root of 2h by g. I hope this relations are already clear to you. So that's why we are just having a revision kind of thing. We are having a revision of it, and we will, so that we can quickly move to the numericals. Next, our initial relation was v square is equals to u square plus 2gh. If I have been said it is dropped freely, what I can have is v square is equals to putting a u equals to 0. While put up a u equals to 0, I can have v square equals to 2gh, and this v is directly proportional to the h to the power half. Yes. And last but not the least, my relation was s is equals to u plus a by 2 into bracket 2n minus 1. This was the relation s is equals to u plus a by 2 into bracket 2n minus 1. If I put u with 0, then my distance that I can represent by h, this h should be is equals to g by 2 into bracket 2n minus 1. And this hnth, this is distance or height traveled in the nth second, is directly proportional to the 2n minus 1. This is directly proportional to the 2n minus 1. Yes. One more very important term is acceleration due to gravity remains the same for all bodies in vacuum. It will remain the same. It doesn't change. We have a pretty options to change the g. Yes, and that we are going to discuss, and we are going to learn these things in unit gravitation of class 11. But here in this case, we assume that g remains the constant. Now this was the case when body was released from height and it is a free fall. Now let's say reverse situation. Suppose body is projected vertically upward, and this is motion in one dimension. This is motion in one dimension. So what would be the situation? The situation would be, let's say apple has been thrown from this with an initial velocity of v naught, and let's say motion of an apple would be something like this. Yes, it is coming back at this position. At this position, it is a position of maximum height. This is h max, and when it is an h max, its final velocity would be a 0. You might know this because if it is having a velocity even at this point, it might go up, but it has reversed its direction. I repeat, as it has reversed its direction, I can come to the conclusion that its final velocity must be 0. Then and then it must be returning. So at that point for a fractions of second, its velocity would be equals to 0, and this is the maximum height. So now what would be the situation if you assume this correctly? If you assume this correctly, first tell me, g is the acceleration due to gravity, that you know. Yes, but what is the direction of g? What is the direction of g? Yes, it is towards the center of the earth. So we can write like this, it is in this direction. So my relations would be v, my relation was v is equals to u plus at. This was I was writing when my direction of velocity and direction of acceleration were same. Now in this case, direction of velocity is in upward direction and direction of acceleration, that means direction of g, is in opposite direction. So I need to write like this, it's a v is equals to v naught minus gt. I hope these things are clear to you. Next, my relations were h is equals to ut plus half at square. So if I replace this a with minus of g, then the relation should look like h is equals to v naught t minus of half gt square. And same way, if I replace this relation with this, then I can have a v square is equals to v naught square minus of 2gh. I hope these things are clear to you. Is it? Is it? So shall we move to the next? Shall we? Yes. So when we projected a body vertically upward direction, as we discussed, we are just replacing a with minus of g. And if we replace a with minus of g, then I can have this relation. First, v is equals to v naught minus gt, h or s is equals to v naught t minus half gt square, sn is equals to v naught minus g by 2 into 2n minus 1, and v square minus v naught square is equals to minus of 2gh. Yes, yes. One more very important and conceptual point is that when I throw this body in upward direction, let's say this is the motion of the body. Actually, this is the one dimensional motion. It should go on this, and from this it will reach to this. But if I draw like this, I cannot see two different paths, that this is the direction or time of an upward journey that we call as in time of ascent, and this is the time of a descent journey, it's a time of descent. So in this situation it is not visible. This is practically situation, and I draw this like this, so then we can have a motion, or we can have a sense of both the motions, a motion in upward journey as well as motion in downward journey. So angle between velocity vector and acceleration vector until the body reaches the highest point, it is 180-degree. Why? Look at this, this is velocity, and if I assume the object here, it's an acceleration g in this case. So it is a 180-degree until it reaches the highest point. And if I talk about the downward journey, what would be its value? What would be its angle? This is v, this is g. This should be a 0-degree angle between velocity and acceleration in the downward journey. I'm talking about the angle between velocity and acceleration in the downward journey. It is 0-degree. I hope these things are clear. Is it? So let's move to the next. at maximum height. Yes. Now, what would be the situation? Let's look. Suppose this is the situation. An object has been thrown with v naught. At this point, as we have discussed, that final velocity would be a 0. So if I write the relation v square minus of v naught square is equals to 2 into g into h, and as this is in negative direction, this should be replaced by a g. I know that final velocity would be a 0, minus of v naught square should be is equals to minus of 2 into g, as I have put up final velocity as a 0. As I have put up final velocity as a 0, so this height would be h max. So I can write it as an h max, and if I solve this, then I can have h max is equals to v naught square by 2g. Please remember this. This is h max, this is equals to v naught square by 2g. Yes, if, yes, one more thing, that in this relation we are not having anywhere mass of the body. That means please listen this very carefully. When if I have thrown an object with v naught and the mass of the object is 10 gram, let's say, and another object is having a mass of a, let's say, 10 kg, but it has been thrown with same velocity, then both the object will achieve same maximum height. This is true. Yes, so h max is independent of the mass of the body. Please remember this thing. It is independent of the mass of the body. I can write like this: h1 is to h2. If I compare two different h max, then it depends only and only if they are on the same location. Initial velocity, that means a square of an initial velocity. I hope these things are clear. Is it? Okay. Now let's discuss about the next point. It is time of flight. We call it as a time of flight, but before it's a time of flight, let's find it out. Time of ascent, and this is time of descent. Yes. So what would be the situation? Situation would be v minus u is equals to gt. Yes, this is final velocity, and this final velocity would be 0. This is initial velocity v naught. As it is in opposite direction, it is g into t, as I have put this as a 0. So if I replace this, it's a ta is equals to v naught by g. This is time of ascent, and I know that my time of ascent and time of descent, that means time required to travel in upward journey and time required to travel in downward motion, they are the same. This is, I am discussing in the absence of air friction. This is, I am discussing in the absence of air friction. So if no air friction is there, I can write that time of ascent and time of descent must be the same. Yes, so what would be the situation when examiner wants you people to consider the air friction? They will specifically mention that please consider air friction. If they have not mentioned anything, it means by default we are ignoring, I repeat, we are ignoring the effect of air friction. So this is the default situation, that you do not need to consider the effect of air friction. But if examiner wish that you need to consider an effect of air friction, then he or she will specifically write on the question that please consider the effect of air friction. I hope these things are clear to you. Yes. So now I know the time of ascent, now I know the time of descent. So I define one term that we call as a time of flight. It is time of flight. What is it? It is a total time taken by an object to complete its journey, or you can rather say that when object has left your hand because you have released the object in the upward direction, and again when it is received by you, the time between this two situation, one you have released and one you have received, yes, it is the time between this two situation that we time as a call as in time of flight. Please remember this. Now the time of flight would be is equals to time of ascent plus time of descent, and it is v naught by g plus v naught by g. Again it's a 2 v naught by g. Yes, again one more very interesting point. This time of flight is 2 independent of the mass. It depends on the initial velocity only. So for two objects having different mass, but they are released with the same initial velocity, then they must be having same time of flight. I hope those things are clear to you. Is it? So are you ready for the questions? Are you? Yes. So let's look. But before we start with the numericals of today's session, again I request you that in previous two classes what you were doing is just look at the question, pause your video, attempt by you guys, try attempting it once, twice, thrice, quadruple and more. If it is not to be done, then again play the video, look at the solution and go to the next question. Even if you can attempt it, go through the solutions. But do not just have a situation that you are playing a video at a one shot, that how sir is doing. This is your examination, not sirs. Please understand, this is very very essential for you guys to learn. So please do it on yourself and then again play it, pause it, play it, pause it, play it, and the journey should be continue. Yes. So let's begin with today's class. First numerical of today's. Suppose they say it is, if an object is thrown in vertically upward direction with a speed of 40 meter per second, then find out first h max, it's a maximum height. Second, ta, that is time of ascent. Third, it's a td, it's a time of descent. Next, time of flight. Yes, you are allowed to take g is equals to 10 meter per second square. So go for it. Please do this quickly. Very very easy. So this is the situation. I have thrown this, so its journey should look like this. This is 40 meter per second. This is the maximum height. So at maximum height its final velocity would be a 0, and this is h max. This is the h max. Its final velocity is 0. First you need to find out the h max. I know that h max is equals to v naught square by 2g. It's a 40 square divided by 2 into 10, because they said that you can take a g is equals to 10. So if it is 40 square, it is a 1600 divided by 20, and this 160 by 2, this is 80 meter per second. Yes, this is 80 meter per second. Second, I have been asked time of ascent. It is equals to u by g. So u, it is a 40, g, it is a 10, it's a 4 seconds. So time of ascent is 4 seconds. Next, I have been asked to find out the time of descent. It is a u by g. Again, it is a 40 by 10, which would be a 4 seconds. Next, I have been asked time of flight. This is ta plus tt. This is equals to 4 plus 4, which will give me an 8 seconds. What was your answers? What was your answers? Do it matching with mine? Is it? Is it? All are absolutely correct. Great work. So, shall I add something? Shall I add something to this? Let's look. Suppose you have been asked that. Suppose you have been asked that. Find out distance traveled by an object in first second of its downward journey. The question is same. The question is same. In the previous question, you need to find out the distance traveled by an object in first second of its downward journey. Now, if you remember, then this was the situation that you released it with 40 meter per second and you have received it at this end. This was released by 40 in upward direction, and this time of ascent was the 4 seconds, so from here to here, and time of descent from here to here, it was again 4 seconds. So if I divide this, first, second, third, just like this is first second, this is second, this is third second, and this is fourth second. A same way, this is the first second of the downward journey. This is the first second of downward journey. This is the second of downward journey. This is the third second of downward journey, and this is the fourth second of downward journey. Yes, but but if I write this, according to the total number of time, that means then this should be first second, this should be second, this should be third, this should be fourth, this should be fifth, this should be sixth, this should be seven, and this should be eight. I hope these things are clear. I'm coming on this question, but before coming to this question, I want to highlight certain points. So please look at them very carefully, and then we will switch to this question. So please listen to me very very carefully. This is very very important points. This is A. Let's say this is B. Let's say this is C. Let's say this is D. Let's say this is E. Let's say this is F. Yes. So one point I want to clarify is that on a same horizontal level, speed of an object is always same. On a same horizontal level, speed of an object is always same. That means I'm talking about the speed. Look at this. So I'm basically talking about the magnitude. So what I can say is that speed at A should be equals to speed at F. speed at B should be equals to speed at E, and speed at C should be is equals to speed at T. Yes, I hope these things are clear to you. On a same horizontal level, speed of an object is always same. Please do remember this thing. These are the golden key points that will help us to conclude so many things very quickly. First, a second, a second. Let's say this is x1, this is x8, this is x2, this is x3, sorry, this is x7, this is x3, this is x6, this is x4, and this is x5. I should say that x1 must be is equals to x8, distance traveled in the first second. Listen this very carefully. Distance traveled in the first second and last second of a journey would be always equal. Same way in this case, x2 would be always equals to x7, x3 would be equals to x6, and x4 is equals to x5. Yes, yes, I hope these things are clear to you. Always remember this thing. You can have a rough sketch of it. Just divide according to the time of ascent and time of descent, and you can have one of the upward journey, one of the downward journey, and you can have a decision that yes, this is my upward journey, this is my downward journey. So in the first second of downward journey, the distance traveled would be the same, as the last second of upward journey. I hope these things and these words are clearer to you. Yes, so let's get back to the question. What they ask is that you need to find. Yes, this was the situation. This has been thrown with 40 and you require this. So what you can do is just divide this journey. On this side it's an upward journey, on this side it's a downward journey. So while consider a downward journey, you can assume at this position u equals to 0, and when u equals to 0, what you can write is h is equals to ut plus half gt square. As you know, u equals to 0, so this is 0 plus half into g into first second, it's a 1, so this is equals to 5 meter. This is the distance traveled. This is the distance traveled by an object in the first second of downward journey. Yes, this is the distance traveled by an object in the first second of downward journey. Is it clear to you? Is it? Yes. Let me add something. Suppose I have been asked that in previous questions. It is only question number 1 that is going on in previous question. Find out distance traveled by an object in the last second of upward journey. a first task should be have a rough sketch of the situation. So this is it. It's a 40 meter per second. Total time required for the 4 second to move in upward direction. To move in the downward direction, it was 4 seconds. Yes. What you have been asked? You have been asked to find out the distance traveled in the last second, of upward journey. So let me divide this. This is first, second, third, and fourth. First, second, third, and this is the fourth second. Up to this. Yes, you need to find out the distance traveled by an object in the fourth second actually. Yes, now how can you do this, or what can be done? What is coming to your mind? One of the option is you can write like this. It's an h1 is equals to u into t1 minus of half into g into t1 square. That means you are going to measure a distance from this to this. So t1 would be equals to 4 seconds. In the second, you are going to do is h2 is equals to ut2 minus of half into g into t2 square. As a t2, you are going to find out this distance. That means, let me show you that this is your h2 and this was your h1. So difference of this h1 and h2, difference of this h1 and h2 will be the distance traveled in last second. So what delta h is h1 minus h2. Here you are going to take t2 equals to 3 seconds. This is one of the options that can be done, and that can be easily done probably. But I am having one more magic with me. So let's have a look what they have asked. They have asked that distance traveled by an object in the last second of its upward journey. So this was a 40 and 4 seconds were required. So this is first, second, third, and fourth. Even we learn one more thing, that this is 5th second, this is 6th second, this is 7, and this is 8th second. Yes, that I have learned that distance traveled in this second and distance traveled in this second would be unequal. Yes, so can I write it's a x1 should be equals to x8. This is distance traveled in first second, and that should be equals to distance traveled in 8th second. Same way, I can write like this, x2 must be equals to x7. Same way, x3 must be is equals to x6. Same way, I can write like this, x4 should be is equals to x5. This is very important to me because I am interested in this distance. So what I came to conclusion is that distance traveled by last second of upward journey equals to distance traveled by first second of downward journey. Yes, and distance traveled in first second, it is very easy because we have a freedom of u equals to 0. We have a freedom of u equals to 0, so that x5 should be equals to half into g into t square, and it is the same as an x4. So if I replace the value of a g by 10, if I replace the value of a g by 10, then I can have as this is equals to 1 by 2 multiplied by 10 multiplied by 1 seconds, because this is the journey of 1 second only. So that should be is equals to 5 meter. I hope those things are clear, and this is much easier and much time saving as compared to this. So please always choose your dimensions wisely. That means if I need to find out certain things, if I need to find out certain things on an upward journey side, I need to find it out on the downward journey side, because for a downward journey I can have a freedom of taking u equals to 0. So let me write this for you guys. Distance traveled in the last second of upward journey or first second of downward journey is always equals and can be calculated as h equals to half into g into t square. For the first second, t is equals to 1 second. So yes. Do you want one more surprise? Do you? Yes. This distance is independent of projection velocity you I hope you know projection velocity, or velocity with which object has been released from ground. This is independent of this. That means let's say this is the first situation. In this, object has been released with this, let's say 40 meter per second. This is the first situation, and this is the second situation where this has been released from 80 meter per second. In both the cases, in both the cases, distance traveled by last second of upward journey or first second of downward journey is same. This is the golden point. You must remember this. This will help us a lot. So please do remember this thing, that distance traveled by an object in the last second of upward journey or first second of downward journey is always same. That does not depend on the velocity of projection, with which velocity it has been thrown doesn't make any sense to find out this distance. I hope these things are clear to you. So let's wind it out here. Yes, in this session we have done a very introductory things about motion under gravity. Yes, these are very basic things. In next classes we are going to discuss some very good applications on the same topic. But before you turn on the next video, please revise this thing thoroughly, as well as practice as many questions as possible. So thank you, have a good day, take care, bye bye.